let us start with our first idealization or first assumption, okay, so which is particle. After discussing particle, we will jump into rigid bodies, okay. So first, when can I call any body to be particle, or in other words, point sized body, okay? When can I treat any body to be particle or point sized body? That is the thing which we are going to identify now, right? First, let me give you some examples, okay. First, consider that I'm traveling from Delhi to Chennai, okay. Let us imagine I am traveling in two different ways. One is I'm traveling in let us consider in a plane, okay, from Delhi to Chennai, okay. So from Delhi to Chennai, I'm traveling in a plane, okay, right. And now, next, same I'm traveling in Delhi to Chennai. Let us consider I'm traveling in train, okay, whatever, right, okay. Now, if you consider the length of or size of the plane, if you consider the size of the plane with the distance between Delhi and Chennai. Distance between Delhi and Chennai means what? Approximately we can take some 2000 kilometers or something. I'm not very sure. Okay, you can just check it in the map or something, like we will consider some 2000 kilometers or something like that. Okay, so something around 1500 kilometers. Okay, something around 1500 kilometer, the distance between Delhi and Chennai. Okay, so the distance something like 1500 kilometers, and it will vary because it depends on in the plane or train in which mode of transport you are traveling. The distance will vary, approximately 1500 kilometers. Now compare it. Now compare the distance between Delhi and Chennai with the size of the plane or size of the train. Okay, size of the plane or size of the train. What you can observe? The observation which we can make is size of the plane or size of the train will be very small compared to the distance between those two, or the distance this plane or train has traveled. Okay, this is nothing but the distance this train or plane has traveled, right? And that we can call it as range of motion. Okay, range of motion. Okay, what is mean by range of motion? The distance this particular body has traveled. Okay, the distance this plane or train, okay, has traveled from Delhi to Chennai. Let us consider another example. You consider sun, okay, the center, and earth, okay. So earth is revolving around the sun. We know that earth is very big, that everybody knows. Okay, everyone was inside the earth, and obviously earth is very, very large. But the distance the earth is traveling to revolve around the sun, okay, so that distance, that we will be taking it as a range, okay, range of motion of earth, okay, which is nothing but this distance, okay, this total distance, okay. Now compare this total range with size of the earth. Obviously size of earth is going to be small compared to the range of the motion. See, I'm not saying that earth is small. Earth is small compared to range of its motion. And when this happens, what? When range of motion of that particular body, okay, when range of motion of that particular body, if it is very large, okay, compared to its size of the body or size of the particle, here we are going to treat that particular body as a particle. Okay, when can I treat any body to be particle? When the range of motion, which is nothing but the distance it is traveling, the distance that particular body is moving, okay, the distance which it is moving, if that distance is much higher than that of the body size itself, okay, if it is much higher than that of the size of the body itself, then I can say that then I can call that particular body to be a point sized body or particle. Or I cannot say that I can idealize it, I can assume it. Okay, it's very obvious, right? A large distance, a very small body is covering. Okay, just consider very large distance, a very small body is covering. So we can treat that small body as we can idealize that small body as a particle or a point. That is, instead of considering the total body size and dimension, okay, instead of considering the total body size and dimension, we will consider it to be a small point. Take an example. Take an example of map, Google Maps. Just open and check it out. Okay, you will get to know that when we are traveling in car and when we are walking, whatever we are doing, we will be considered, that is the person who is taking the direction will be considered as a point only. Okay, you would have observed it, because compared to the complete range which the person is going to travel, that particular person is very small. So compared to the range, that person is small, so I can treat that person as a point. That is why whenever we are using the direction in Google Maps, we used to be as a point only. They used to treat us Google Maps used to treat us as a particle or point-sized body. That's it. Okay. Now, similarly, that is what I said. When there was different forces which is acting in a body, and if I treat that particular body as a particle or point-sized body, okay, if I treat that particular body as a particle or point-sized body, then what I can do, there are different variety of forces which is acting in this body, right? If I able to treat, when I able to treat it as point-sized body, if the range of motion is much higher than that of the body size, okay? If that happens, then instead of representing it like this, okay, we can represent it just as a point, okay? And I can represent all the forces which is acting on this particular point, okay? So this is the actual body, but I am representing it as a particle or point-sized body. Now, important point to note here, I am saying that we can treat it as a point, Can I take any point there? Can I take any point and I can say that I could represent this particular body like this? No, it is not. We have to use the center of gravity, okay? We have to use the center of gravity. What is center of gravity? We will discuss it later in our separate videos, okay, separate chapter. So in that center of gravity, okay, that center of gravity has to be considered as a point, and we need to consider this total body in that particular point only, okay. This approach is something which is very famous in Newtonians, okay. That is, this is what we will be calling it as Newton's approach, okay. That is treating a complete body to be point, okay. Now, coming to problems point of view, fine, you understood what is mean by particle or what is mean by point-sized body, and you understood that how to represent it, okay, how to represent all the forces. I just need to represent it at the center of gravity, well and good. And when I need to use, fine, but when I need to use in problems, because in problems they are not going to specifically mention it's a particle, it's a point size, they might mention but not always. So when I need to use it in problem, simple logic, remember this, when dimensions, okay, when the dimensions or shape or size of the body is not mentioned, okay, if it is not mentioned, if dimension, shape or size of the body is not mentioned, then I can treat that body as a particle or point-sized body. For example, in a problem they are giving you a car is traveling a distance of 100 km at a speed of some 20 km per hour, then find out acceleration or something like that. In that case, they didn't, in this particular problem which I defined, they didn't talk anything about dimensions of the car, right? So I can treat the car to be a point-sized body, okay, very simple. Remember this, we will proceed to rigid body now. So now let us understand what is meant by a rigid body. If I take rigid body, there are two different types of definition to be said for rigid body. In general, if I ask what is meant by rigid body to any student, their response will be body which cannot be deformed, okay. A body which cannot be deformed can be said to be rigid body. The definition is some kind of partially correct, but it is not completely correct, okay. So we have two different types of definition. One is a static definition, another one is dynamic definition. So first let us see the static definition, okay. If I take a body like this, any body you consider, let me take an example here, okay. If I take a body, okay, if I take a body like this, I'm marking 2 points, okay, point 1, point 2, okay, I'm marking 2 points here, so P and Q. And I'm applying different types of forces on that particular body, something like a force, a moment, different forces are acted on this particular body, I'm applying different forces. Okay, even after application of whatever may be the force, you apply 100 Newton, 1000 Newton, any number of force, even after application of whatever may be the force, if the distance between these 2 points, okay, distance between point P and point Q, see, the one point you need to note here is not necessary that I have to take only this 2 point. You can take any point as of your wish. You take any point, this point, that is you take PQ, or you take this 2 point, or you take this 2 point, you take this 2 point, or you take this 2 point. The ultimate aim here is the distance between those 2 points, okay, the distance between those 2 points, even after application of whatever may be the force. Okay, you apply whatever may be the force, let it be moment, let it be force, or whatever the quantity of the force may be, the distance should not change. The distance should be invariant, the distance should be constant. Okay, so L has to be constant. Okay, so distance between any 2 point, okay, it's not necessary that only that 2 point, okay, any 2 point should remain constant. If it remains constant, then I can say that particular body has a rigid body. This is static way of defining it. Okay, static definition of rigid body. Okay, so this is static definition, keep it in mind. Now coming to dynamic definition, again I'm taking a body and I'm taking any 2 point again. Okay, so that 2 points are P and Q. Okay, and let us consider that this particular body is moving. Okay, so here also there is a possibility that this particular body is moving. Even if the body is moving or stationary, whatever force it applies, whatever happens, the distance should remain constant. If it is constant, I can say it is I can say it is rigid body. This is static definition of rigid body. And coming to dynamic definition of rigid body, you take any 2 points P and Q. One point is having a velocity v and it is inclined at this particular direction. Okay, let it be. It is inclined at theta 2. Okay, and at point P, velocity v1 and let it be theta 1. Okay, now so 2 points, different velocities, and it is acting in a different direction. Now the question, the definition is something like this: the relative velocity between the 2 points. Okay, relative velocity between any 2 points, again relative velocity between any 2 points along the direction along the line joining these two. Okay, along the line which is joining these two. So you could see that P and Q, this black color dotted line is the line which is joining P and Q, right? So along the line which is joining these 2 points, if the relative velocity is 0, what is meant by relative velocity? Velocity of P with respect to Q, velocity of Q with respect to P. Let me give you an example. Okay, we'll take an example here. Okay, so there are 2 cars. Okay, let car A and car B. Okay, this is moving at some 20 km per hour and this is moving at 30 km per hour. Now, if this is moving at 20 km per hour and if this is moving at 30 km per hour, obviously B is going to overtake A, right? Which means this distance is going to decrease. Obviously, it's going to decrease and then B is going to overtake A. If suppose, if this is 20 and if this is 30, okay, that is for 1 hour this is traveling 30 km. In 1 hour it is traveling 20 km. So again, obviously, this is going to travel much faster than that of this. So this distance will further increase, right? So there is some relative velocity between these two, that is velocity of one with respect to other. Okay, so if you take relative velocity, for example in this case velocity of A with respect to B, okay, I will talk about this relative velocity, relative motion a bit more when we enter into rest and motion. As of now you understand this. Okay, so velocity, relative velocity of A with respect to B. A is traveling at 30 km per hour and B is traveling at 20 km per hour. So obviously this is moving at 10 km per hour faster than that of B. So with respect to B, it is moving at 10 km per hour. Wait for a moment, I will talk about this bit more later. Okay, right. And when this two, the distance between these two will remain same throughout, only if both are traveling at a same speed. If A is also traveling at 20 kilometers per hour, B is also traveling at 20 kilometers per hour, the distance between those two will remain constant without any changing, Obviously, that is what we need, right? And that is what the definition, the dynamic definition says. What it says, the velocity along the line joining, okay, so very important, only in this direction velocity only. We are not worried about the velocity perpendicular to it, we are worried only about velocity in this direction. So B is moving in this direction at 20 kilometers per hour, A is also moving at 20 kilometers per hour, then obviously this distance won't vary, so it is a rigid body, okay. So first of all, for point P, what will be the velocity in this direction? This, right? This is going to be the velocity, which is V1 cos theta 1. I'm resolving it in this direction. Angle known side, if I resolve, it will be V1, it will be cos theta. Regarding this, I already explained in a separate video in our basics, okay. Resolving of vectors, there will be one video, resolving of vector or resolving of forces, you can check that, okay. V1 cos theta 1, and if I resolve in this direction, that is perpendicular to this line, okay, perpendicular to this line, it's going to be V1 sin theta 1, okay. And similarly here, this is going to be V2 cos theta 2, and this is going to be V2 sin theta 2. So according to the definition, what it says, relative velocity between any two points with respect to each other along the line, this is the keyword, okay, this is the keyword, along the line which is joining should be 0, which means velocity of P with respect to Q or velocity of Q with respect to P should be 0, which means both of them should travel at the same velocity along the direction. So this implies velocity of P with respect to Q or velocity of Q with respect to P as 0, okay. So I hope it is clear, right? So velocity of one point with respect to other point in the direction, along the line which is joining them has to be 0. But perpendicular to it, it can be 0 or it cannot be. I will explain that through an example, okay. So there is no necessary that this velocity, okay, V1 sin theta 1 and V2 sin theta 2 should be same. It can be same or it can be different, no issues at all. Wait for a moment, I will explain with an example, okay. So this is a dynamic definition, okay. So static definition says distance between 2 points should remain same, it should be invariant irrespective of whatever force you apply, okay. And the dynamic definition says relative velocity between 2 points in the line which is joining, okay, along the line which is joining those 2 points should be 0, okay. Relative velocity should be 0, which means velocity should be same along the line which is joining, okay. So I said that for a rigid body there should not be the relative velocity between 2 points in any 2 points along the line joining the 2 points should be 0. But can the relative velocity will there be any relative velocity perpendicular to the line joining? That is what we are going to see. The first example I am taking here was, I am taking a body here, I am taking 2 points and both these 2 points are subjected to same velocity v, okay. There is a body and let us imagine like this, 2 points are there and both the points are subjected to same velocity. So obviously what will happen? The body is going to move, just the body is going to translate, okay. So the body is going to just translate, right, with the same velocity v, okay. So it will look something like, I'm just drawing it approximately, okay. So the body will just translate, imagine the same body, okay, the figure may be big but it is the same body, imagine that it is the same body. So only translation is happening, okay, only a movement is happening. And obviously if you see now, what is velocity, can I treat this body as a rigid body? First and foremost question, of course yes, I can treat, because along the line joining there is no change in the velocity, no. Of course I can treat it to be rigid body. The reason is there is no relative velocity along the line joining these 2 points. Now what about the relative velocity perpendicular to the line joining? You can check out the velocity of Q, velocity of P, velocity of Q or velocity of P, both remain same, there is no change, right. So what will be velocity of P with respect to Q? It is also moving at V, it is also moving at V, so V minus V, which is going to be 0. So relative velocity was 0. So in this case, when there was pure translation, only translation, relative velocity between the 2 points, even at the perpendicular to, okay, even perpendicular to the line will be 0, okay, which means the velocity will be same. Now coming to this case, I am having a hinge here, okay, and imagine that I am holding it here, there is a hinge, I am applying a force like this, okay, I am applying a force like this, so it is just rotating, okay, it is just rotating, it is not translating, it is rotating. So now what will happen? Let us consider like this, okay, it is rotating and it reached here. Okay, imagine both the bodies are same. I am not drawing it correctly, but both are same. Okay, this body is just rotating like this. Okay, I am hinging here and this body is just rotating. So what will happen if I take 2 points, something like one point here, another point here. It is the one point is rotating here and another point is reaching this place. Okay, let this be P and let this be Q. Okay, and obviously you could see that in a given time, okay, so it is rotating, right? For example, I am rotating it in 5 seconds, okay. In a given time, point P is traveling a distance, let it be L1, and point Q is traveling a distance, let it be L2, and obviously we clearly know L2 is greater than L1. It's very obvious, right? This distance, okay, this distance, let it be Q dash, let it be P dash. This distance is greater than this distance, okay, so L2 is greater than L1. So if L2 is greater than L1, what will be the tangential velocity? This is, let it be VQ, let it be VP. If L2 is greater than L1, so obviously velocity of Q is going to be greater than velocity of P. For a given time, okay, in the given time for the 5 seconds, Q is traveling more distance compared to P. Okay, so the distance traveled by Q is L2 and distance traveled by P is L1. So L2 is greater than L1, so obviously velocity Q will be greater than velocity of P. So what is happening in this particular case? Very simple. Let me show you. Velocity of Q is greater, right? You could see here velocity of Q is greater than velocity of P. So now velocity of Q with respect to P is not equal to 0. The difference between these two, VQ minus VP, will give me the relative velocity. So relative velocity is not equal to 0. This is what case? This is the case of rotation, right? In fact, it is a pure rotation. Let it be, right? So when there was a translation, okay, relative velocity between the 2 points, even perpendicular to the line, will also be 0. If there was a rotation, then you could see very clearly that this distance is not varying, right? Distance between P and Q is not varying along the line which is joining, it is not varying. So along the line, no relative velocity, but perpendicular to the line, okay, perpendicular to the line, there is some relative velocity, okay. So what is the final conclusion for the rigid body? Along the line joining any 2 points, there should not be any relative velocity. Relative velocity should be 0. Perpendicular to the line, okay, there can be, may or may not, okay, may or may not relative velocity exist between 2 points, okay. So these are the things which you need to note. Relative velocity may or may not exist perpendicular to the line joining. Relative velocity should not exist. Relative velocity should be 0 along the line joining 2 points.